Hey everybody, how's it going? This is Patrick with Stacking Layers. Today I'm going to be showing you how to set up Bigtreetech's all-new EBB Generation 2 board using USB communication. I've already done an unboxing, kind of a first view on this board, so went really in-depth on what is all new on this board. I also used that video to show you how to set up a CAN bus. A few of you reached out and asked if I can do a USB version, so I am doing that. One thing to point out, as you can see here, I'm using the EBB36, but if you have the EBB42 version, you can still follow along with this because the only difference is the form factor, the size. Everything else is identical. So really easy, just continue following along and everything will work. So first things first, let's get this board ready to talk in USB. So what Bigtreetech did is a really cool thing here is they've used what's called a MUX chip, and that allows switching through different things. It has a little digital chip in here somewhere that will switch which wires are connected, basically. It's a digital switch. And to control that is this little jumper here. This is the one that's used to control whether you're in USB mode or CAN bus mode. As you see it now with these two jumpers on, that is in CAN bus mode. This one on the side is for the 120 resistor, for the termination resistor. That is not used at all for USB, so we get rid of that one. And because we want USB mode, we take this one off also. So when both are off, now you're in USB mode, ready to be used as USB. But we still have to flash the firmware so it knows, so the little chip in here knows how to talk via USB instead of CAN bus. All right, so we'll take care of that. But first, I got to go over a couple little extra things here. This little board in the middle here is a very important addition. This is, as you can see, it says USB adapter. This one is a must use. This is not an option. You have to use this. It comes with everything, so you don't. It's not something actually you have to buy. But this one you must use when in USB mode because this offers a lot of protection from things like short circuiting, reverse polarity, some sort of weird stray electricity happening through your USB communication. What it's doing is protecting your host computer, your Raspberry Pi or whatever you're going to be using, from being burnt out if something weird happens and allows a lot of electricity to dump through the USB communication. That's pretty much one of the weak sides of using USB. Is there's a lot of like the previous EBB boards, they had a USB plug on it for programming, but people have found you can also communicate and then do some rewiring. That's a very risky thing because of the fact that if you lose power, if for instance the 24-volt wire breaks or comes disconnected somehow, while you still have USB and everything else powered up, it can dump a massive amount of voltage backwards through that USB connection and fry your host computer. So it's a very dangerous way of doing things, and that's really one of the main reasons why Bigtreetech took so long to get this thing set up, is because they want you guys to be able to experiment but still be safe. And so that's what's going on with this board. You got double fused power input for overcurrent problems. You have a MOSFET system that's helping to mitigate any type of problems with reverse polarity, stuff like that. And then you have a USB hub for other, you know, mitigation of other problems. And it's also kind of mirrored through here, not fused, but it also has a separate hub. So there's a lot of protection going on. So this thing is a must use. Okay, it's just the way it is. So the way this thing gets connected is very simple. You have your host computer, your adapter, and that obviously. So the way it works is all the cables are supplied. You have a USB-C, so USB A to C. This is for data only. Do not try to do power delivery through USB-C. That's not how this is designed. So it's only for data. So obviously that's going to go from your host into there. This um, this terminal here is for your power input. That's the power that's going to be supplying power for your heaters and motors and all that. Typically a 24-volt setup. So that's going to get power in there. If you see on the bottom here, you can see it's ground and VIN. So it's your voltage input and your ground connections. Ground is the one that's connected closest to the USB. So in case you already have this mounted and you haven't seen that, that's where your ground is going to connect, okay? And then your power is on that side. One little side note is when you're connecting ground, make sure your ground connections are all common. So if you have a different power supply, like say you got a Raspberry Pi and you're using a 5-volt power supply, make sure that the 0 of the Raspberry power supply is also on the 0 of the 24-volt supply. So everybody's connected because communication needs to have a common ground point. So everybody is on the same page, basically. Everybody's talking the same 0 volt. Okay? Otherwise, it's called floating volts, and that can cause problems. You don't want that to happen. So that would be power. On the other side, these two outside terminals, you don't need to worry about. This is for CAN bus, and this is for power output, which we're not going to be using for this setup. The one we're going to be focusing on is the center one. and that is for, again, the supplied cable. That is for the one that obviously fits in the hole. There's only two types, and there's only one that fits there. Um, so you don't have to worry about, wiring things up and getting things in the right pins. It just plugs in straight there, and then the other side plugs in to the EBB board. And the reason why they went with this type of thing, this is pretty much what a lot of the companies are going with now. But there's a key reason besides the fact that it's nice and easy to plug in and hard to plug in wrong. But it also is because it has the data points lower than the power point. So the power is engaged before the data. Again, it's another stage of protection so you don't accidentally blow things out. So that's that. And then Bigtreetech went with this smaller style um, to make it easier to fit through holes. It's still a little bit larger, but obviously a lot less large than this guy, which won't fit through holes. So that's that. So let's get this thing connected and powered up. So first, obviously, we need power into here. So we have our 0 and 24 volts coming in. When you screw these down, I don't know if you've ever seen this, but hold on to your terminals. Don't just screw down really hard with, the board secured like that, because you don't want to twist these things. Twisting down inside will actually twist where they're soldered in, and that can actually crack the solder. And over time, you may not notice any issues at the beginning, but over time, those cracks will start causing heating issues. And basically down in here, you'll get little fractures, and it just keeps getting hotter and hotter and hotter and starts melting out the solder and starts burning up your boards here. Also, don't use tinned tips. As a matter of fact, they come pre-tinned. Cut those off. If you don't want to use the furls, the little termination terminals there, just cut these off, and you can use bare wires in these. These are designed for bare wire connections. Just make sure you don't have any stray wires that are bridging across right here. Okay, but don't use terminal or soldered tips on these things. Just a word of advice that'll prevent future problems of these things melting down. All right, so that's that. Power into there. Next step is obviously USB data connection. That's pretty simple. That gets plugged into one of your USB ports, the right direction, and into obviously the data USB port. Again, it's the only place it fits in. Pretty straightforward. Then the last one is going to be the long cable that plugs into here and to the EBB. Make sure it's fully seated, clicked in. It'll hold on very tightly. And then the other side into there. All right. Now you're all nice and plugged in, ready to go. Obviously, I'm showing you off of the printer, but things will probably be installed already. It is a good idea to have things pre-programmed before you start plugging stuff in. Just make sure things are communicating properly first. So this is how I normally set up my boards, but if you already have it plugged in and everything, that's fine also. So that's how you connect it up. Now let's get it programmed and ready to go. We're going to jump over to the computer, but before we do that, why don't you check out my video sponsor, PCBWay, and we'll be right back.
Do you need high quality 3D printing for your next project? Well, PCBWay's got you covered. With PCBWay's rapid prototyping service, you can bring your ideas to life in a huge range of materials, from durable plastics to sleek metals, all with precision down to the tiniest detail. Whether you're making functional parts, prototypes, or just something cool for your desk, PCBWay offers multiple 3D printing technologies like SLA, SLS, and FDM, all at compatible prices. Simply upload your design, choose your options, and PCBWay will handle the rest. It's fast, reliable, and shipped straight to your door. Turn your ideas into reality with PCBWay's 3D printing service. Check out the link in the description and start creating today.
All right, welcome back. So as you can see here, I am in main cell with an error because my board's not set up. Before we dive too deep into how I'm setting this up, I do want to point out that I have my configuration, my printer configuration is strange. This is just for demonstration purposes, so yours is going to look different. And so as you can see, mine is very basic because all I've done is set up my Raspberry Pi or my Bigtreetech Pi that I have here, set it up as the main MCU. And that's just because I don't have another MCU board attached. And then the EBB is set up as a secondary like you would normally use it. And then other than that, I just have a little bit of a base printer with a none kinematic. So that basically it's not looking for anything specific. It's just a demonstration. But obviously yours is going to look different because you're going to have all the stuff already set up for your main controller board. And then you're gonna be adding the EBB, of course. So that's why mine looks weird. So don't worry about that part. This is predominantly set up to show you how to get things communicating properly over USB and the basics of setting that up. The printer config side of it is a whole nother story. If you guys need help with that, obviously drop down in the comments, or maybe if enough of you respond, then I can do a little bit more in-depth video of how to do configuration stuff. I do still want to do more about printer config. I do have one video if you guys check it out. Maybe I'll put a little link up here so you can check that out too. Give you the basics of how the printer config works, but that's not what this video is about. All right. I just wanted to point that out so it's not confusing on why mine looks so minimal. But obviously, we're not able to communicate right now. It's completely errored out because this board is right now set up as as CAN bus mode. So obviously, Klipper can't talk with it right now because it's not plugged in properly for that. So let's get this set up. First thing first, you want to make sure that your system is up to date. It's always good to have everything up to date, specifically Klipper. As you can see, I have a newer version available. So I'm just going to go ahead and do all the updates and get that thing set up. It's also, if you have any system updates, those are going to be your two primary most important things. Moonraker is good to have updated, of course. Crow's Nest is not as vital for what we're doing today. The vital ones are going to be Klipper and the system package. You want to get everything up to date. Keep in mind though, if you have another board already set up and that one is already set up on a previous version of Klipper, you want to keep everything on the same version. So if you don't want to do any updates to your previous board that's already connected, then just leave it as it is and continue on with the next step. Okay. I do recommend though getting everything updated and being on the newest setup. So we'll do the updates and then when that's finished, continue. Alrighty, update is done. And of course, it's still not going to connect because we haven't set up anything. Okay, so I'm going to be doing something a little, I guess, unconventional or a little bit maybe not everybody knows about. But even though we're using USB, I'm still going to be using Catapult. Catapult is most time used with CAN bus because it makes it easier to update things. But for a lot of people, they don't understand or they didn't realize you can also use it with USB. So we're going to set that up. And again, it just gives it an ease of updating. So you don't have to come through pressing buttons if you want to do updates in the future. So first thing we have to do is SSH into the board. That's secure shell. So you can obviously use your host computer or communicate through your host computer remotely. I'm going to use command prompt since it's just easiest for me now, built in. You can use putty or whatever you want to use to get into your host computer. If you're using command prompt, it's easy as just doing SSH space, and then you put your the username for the host. So here I'm just using the Bigtreetech Pi, so it's BQ, and then the @ symbol, and then the IP address for your host computer, or if you know your host name, you can use that too. So I know the host name. This one is just I set it up as CB1, and then you put the .local if you're using a host name. If you're using the IP address, you just put the IP address of the host, and that's it. So like this, and then you hit enter. If it's your first time ever, you might get a message popping up saying that there's going to be like SSH key. You'll see like a long hash key. Is asking if you want to add it or not. Just type in yes, and go forward with that. Obviously, you need your password, and we're in. So obviously, like I said, we're going to be doing catapult. So we want to first make sure that our catapult is set up and up to date. If you've already used catapult, it should be. But if not, then what you want to do is to basically do that. You want to set it up to get everything going. So I'm going to put this in the description. It's just a real kind of it's a one-liner thing to do a check if you have the latest version, if you already have it installed, or if you don't, it's just going to pre-install it. This is from Esoterical's CAN bus guide, so it's a really cool guide. I'll put that in the link also. Sorry, down in the description. But this link here is going to do that. So this is going to be a really easy copy paste thing. If you want, you can pause it and type it all out. But I recommend doing the copy paste from down in the description because all of these spaces are vital to be where they are. Otherwise, you'll get things messed up. So you just put that in and you run the command. And it's going to do, like I said, it's going to check. It's going to make sure that everything is up to date. If there's any updates, like looks like there was, it does this fast forward and it updates anything that's been changed. So we're good to go there. Very simple. Next step would be to get into the catapult folder. So you do CD for change directory and then catapult, enter. And now we're in that directory. It's important that you're in the catapult directory to start because we're going to be first making the catapult firmware to get things in motion. So from there, you do the command make and menu config. And now we are in the catapult make menu. This is, as you see here, it looks very similar if you've done Klipper stuff in the past, which I would assume you have because you're doing some upgrades here. But this is catapult configuration instead of Klipper configuration. Pretty straightforward. I actually have already used this on my EBB, so it's already filled out to what you need to use for CAN bus, but we're going to be doing for USB, of course. If you have never come here before, it's your first time in, things will look a little bit different. Obviously, you won't have any standard stuff or anything filled out here. But the first thing you want to do is obviously select the chip. This one is an STM32 chip. The next one, as you see here, is the STM G0B1 chip, which is down there. And I'm just navigating with the arrows up and down and enter. Next one here, you want to build the catapult deployment application, and it is the 8 kilobit bootloader. So we're good there. This board specifically uses the 8 megahertz crystal, so make sure that's right. This is an important thing because if you have the wrong clock, this is what controls the clock speed of the main chip. If you have that wrong, it's not going to communicate properly. So it is 8. Now we want to do our communication interface. Obviously, like I said, we're not doing CAN bus, we're doing USB. And on this one, it is the USB on PA 11 and 12. It's the only option they have on here. So you're good there. Select that one. And then we want to make sure to have an application offset of the 8 kilobytes just to, yeah, that's just where it goes. The other option is 4. We don't want that. We want the 8. USB IDs. This is cool if you want to. You can actually change the different IDs. But I'm just going to leave it alone because not everybody comes into this and it might get a little confusing. But there are ways of changing that stuff, but I'll just leave this alone right now. So just leave that default. GPIOs to set at bootloader entry. Um, you don't really have to worry about any of that type of stuff because there's nothing. Some boards have like a pin that needs to be held high or something. This is custom stuff, so just leave this alone. This one you want to support reentry at rapid double click. This is good to have on. So that little star means that it's on. And the reason why you want that on is because if for some reason the command line code doesn't put it into bootloader for updating in the future, you can also double tap the reset button on the EBB, and that'll also put it into bootloader mode. That's good to have on. This one, you don't need this to be enabled for bootloader entry on GPO. So this could be if you have like an extra button somewhere that you rewired one of the pins, you can technically have a button somewhere else that's connected to force it to go into bootloader mode. But a little more advanced, not necessary here. This one is a nice feature to have to enable. So this is the enable status LED because on pin PA2, as I have defined here, PA2, that is the LED that will blink for it's a status LED. So it'll let you know if it's in bootloader mode or not. So it'll blink if it's in bootloader mode. So it's a nice feature to have, but not needed. It's just something cool to have. So that's all that you need for that. Once you have that set up, then you hit Q for quit. You should get a little thing prompting to save. Hit yes, and it'll back out to the main to your command prompt again or to your terminal. So from here, the firmware is set up but not made. So that's the next step. You just type in the command make. Hitting make and enter will start making the firmware. Okay, and so once that's all done making, now is time to flash. But we do have to do a couple little things to get it ready to be flashed because, like I said, we're doing bootloader for catapult. So we want to make sure that that's set up in the right mode. So what we need to do is to go back to our EBB here and make it into boot mode. Let me switch over the screens here so get a little bit closer up. So on the EBB, you have these two buttons on the sides, top sides. The one on this side is the reset, and this is the boot. So what you need to do is hold the boot button in. While you're holding that in, then you want to tap the reset. After the reset's been let go, then you can let go of boot. And that's going to put it into bootloader mode. One thing I can point out, if you notice, I don't have any green light in here. Nothing's blinking, nothing's on right there. But when I put it into bootloader mode, then a little green light turns on. That's another indicator to let you know that it's in that mode. But to be even more thorough, we come back to the terminal here, and you do ls usb as the command. Ls usb, and this is going to be checking what kind of USB things are plugged in. So what you're looking for is not showing up. Make sure I have the USB plugged in well. There we go. As you see there, I had to switch ports. Sometimes some of these ports don't talk right or they don't set up right. But when I switched over, now you can see this is what we were looking for, is the DFU mode. So as you can see, that's a good thing that it did that. Sometimes this happens. You won't get anything. It seems like it's not communicating. Um, and it really is as simple as just changing a different port, USB port, and it'll start working. So don't be afraid if you don't see it working. If you don't think that it's a damaged board or anything right away, do one of two things, or both maybe. Switch the ports or switch the cables, or both. Because even some of these USB-C cables, you might have a longer one that you're using, and a lot of them are coming now where it's literally only power. They're charge only cables. The data connections are not even actually connected properly inside, so it can't even do data. So that's a good thing that that failure happened. So I can show you that these type of things do happen. All I did was switch the port from this side to this side, so it's a different port number, and it worked fine. And there are two different USBs that are showing up now. So we have this one, this first USB, the Hashang, however you say that, electronics. That's the USB hub on the adapter board. And then this next one is the terminal. Ignore this here because this is my CAN bus adapter over here. So that has nothing to do with this. That's just why that's showing up there though. So this is the one we're looking for. This lets us know we are in DFU mode. That's the important thing. So that shows that we're ready to receive the catapult firmware. And to do that is a fairly simple but very long command. So what I'm going to do is to just basically copy paste. It's the easiest way of doing it here. So I will copy that. Of course, this will be in the description down below. And I will point out one very important thing is this number here, the ID. As you see, it's the 0483 DF11, and it's also matching with what's already here in the thing that I pasted. But it's important that this number matches after the last numbers there. I have honestly not seen an STM device that does not have this ID. If for some reason the manufacturer decides to update this ID, then it'll be different. So whatever this is with the one that's in DFU mode, that's what needs to go here. Okay, so that's just something to be aware of. If it's the wrong, it's going to flash the wrong area, or it's not going to flash at all. But once you see it's all matched up, everything is good, you hit enter, and it should start the flash process. Oh, of course we need, because it's in sudo, we need our password again. And there we go. Very quick, very simple, easy peasy. So as you can see, it did the erase. It made sure it was erased, and then it uploaded, or sorry, downloaded as it shows, and it shows it as successful. Do also want to point out, you get this last part here. It says error during download. That can be confusing. That has nothing to do with it erroring out. That doesn't mean that it didn't flash. All this means is that it was not able to check afterwards, because what it's looking for after is that it actually did flash, but because it automatically kind of resets, then that reset doesn't allow it to see the flash. Like you would have to put it back into DFU mode while it's checking, but because we have to use those buttons, you can't do it fast enough. So it's going to error at the last part, but don't worry, that's not a true error. Okay, so we can go back over to our board, and you can see now. I'm getting in there. You can see that little green light is flashing. That's because we allowed that status light in the firmware. So now it's letting us know that it's in bootloader mode. It's not in DFU mode, but it's in catapult mode. It's ready to get a new firmware. And now we have to build the firmware for Klipper. So let's do that. Go back over to terminal. Of course, we don't want to do catapult anymore. We're done with that. So let's change the directory again. Use the dot dot to get back one directory, and then /, and then we want to go into the Klipper. Now, as you can see, we're in our Klipper directory, and this is where we're going to do the same thing with the make menu config. Oops. And now we're in the more familiar, probably, is the Klipper firmware configuration. So really straightforward. And in reality, we're using pretty much the same stuff here. Again, if this is your first time coming to here, you might see something that looks like this, very basic, without even any of the STM stuff here. But let's get that set up. So first, enable the extra low level configuration stuff. And that's just because most of the guides, it's not really needed, but most of the guides show it with it enabled, so it makes it look familiar. Of course, same idea. You want to make sure that you're doing the STM32, and it is the G0B1, and you want to do the bootloader offset, 8 kilobytes, and the same thing, 8 megahertz crystal. And of course, we're not using CAN bus on this. We want to do USB. Make sure that's enabled. This is what I was talking about. Those are the USB IDs. Again, leave them alone. You can change them, but just leave them alone for now. Other than that, the optimized stepper code, just, yeah, go ahead and leave that enabled. That's something new, but it doesn't really pertain to this board, but it helps with Klipper talking with the steppers and stuff like that. So just leave that on like that. And then the rest, the GPIO pin also, we don't need to do anything with that. That's all we need. We're all good. Same thing, hit Q to quit, Y to save, and then make. And this is the Klipper side that we're making. Okay, so now that you have the firmware made and everything is set up, you want to make sure that it is communicating properly so we can do the next step. So quickly check that USB is working. What we want to do is you can check with the LS USB. Let's just get that out of the way first. And as you can see here, now it's no longer in DFU mode. It's just the standard STM communication mode. So that's good. That means that it is properly communicating via USB. You can see that you have these other two hubs here. This is the terminus is the one that's on the EBB, and the Hashang is the one that's on the adapter. So that's good. All these three are up and running. So that means everybody's communicating well. And you can go further, which we actually do need to grab this information. You do the LS, that's the list. And then what we want to do is look for the actual serial. So that's in the dev folder under serial, and then by ID. Yeah, by ID. And then you want to end that after the slash. You want to end that with a star. That's just as a wild card is what it's called. And that'll list everything that's available. So we check it out, and there's obviously only one. If you have another board connected, for instance, your main controller board, you'll probably see one that pops up with USB and it has Klipper instead. So make sure that you're looking at the right ones. If you have multiple ones and you really don't know, you don't see anything that says catapult, for instance, then that means catapult is not communicating. But if you have like catapult and then like another board that says Klipper, then you know the catapult one is the newest one that we're messing with. Obviously, if it's a different main chip, that's another way of knowing right away which one you're talking to. Then, if you have one that's another, what would it be like an F something there instead. Anyways, so make sure you get the right one for your board. Obviously, I only have one, so there's only one showing up. But now what we're going to be doing is using Catapult, because this means that it is running well. Everything's good, ready to go. We're going to be using Catapult to flash the Klipper firmware. All right, and that's where Catapult becomes a good handy tool because you no longer need to do anything with the EBB board. So this can be installed in your system, and you don't have to worry about pressing buttons anymore on it. So to do that, because we're using USB for Catapult, there is an extra feature we need to add, which is Python serial, and that's just for serial communication. So you want to make sure that that's up to date or installed if you haven't ever done it. It's really easy. You want to update your system, or to update your apt list. So that's sudo apt, and then you run that. It's going to ask for the password, probably. No, it may ask for your password. This is just going to update your libraries or your apt stuff. It's letting. This is just kind of a side note thing. This is letting your system know all the available updates that are out there. It's not actually updating anything. It's just gathering everything that's available. So it could take long. It just depends on how often you do this. Okay, so now that's all done and taken care of. Don't worry about right now. It says 3 packages can be upgraded and stuff like that. I'm not going to really mess with that. As long as you did the other thing that was over here on the updates here, as long as you got all that up to date, you're good to go with this stuff. So don't really worry about that. Um, but anyways, what we need to do is to install the Python or to check that it is installed, the py serial. So again, that's going to be a sudo command, and then we want to do apt install, and it's Python 3 and dash serial. Python 3 dash serial. And this is again just to make sure that you can communicate via USB serial. So it's installed and it shows I'm already at the newest version, but obviously if you didn't have it installed or if it was an older version, it'll upgrade for you. So all good there. Now we're ready to go to the next step. And that's where getting these type of information comes in to play. So what we need to do now is use the flash tool from Catapult. So you want to get back into the Catapult directory. So you can do cd, and I'm going to back out this way and then get into Catapult. So we're in our Catapult directory, right? So make sure you're in there because we're going to be using Catapult scripts. And so that would be the next thing we want to do is get into the script folder, scripts. And if you do an ls, you can see why I'm doing that. You'll see we have our flash tool right here. So we're going to be using this tool here. Okay. So to do that, what you need to do is run the Python. So it is a Python script. We do Python 3. If for some reason it doesn't work with this, you can take away the 3. Some systems are set up to where just Python is enough. Other ones, it needs the 3 on there. So try that. If you get an error, you can try to add the 3 or remove the 3. For mine, it should be Python 3. And then we want to use the flash tool, flash tool.py. And then what we're going to be doing is telling it the device that we want to flash to, space, that's what the dash D is, which device. And then we want to copy this here and then paste it there. And that should be enough if I recall properly. It's been a while since I've done the USB thing, but that should be right there. And then we hit enter and it should start flashing. There we go. So it's doing its thing, it checks and all that good stuff. And now here, see this verification thing? This is kind of what that DFU was trying to do in the past. But since it gets automatically reset after flashing, it can't do this part. And that's where that error is. That's all that was in the earlier part of the video. This one, as you see, it was able to verify that this number is a verification that it was completed. That basically the firmware number matched with what is installed. So that's a good thing. Programming complete. It's done. And now if we do that ls command for, let's go up. I'm just hitting the up arrow if you don't know about that. ls the dev serial, we should see it say Klipper. And yes, it does. There we are. So now we are running Klipper. So we're good to go. Now this part here is what we need for the next step. So make sure if you're going to close down your SSH, make sure to copy this somewhere safe because we need this entire line all the way from that / to the end. This must be saved somewhere because this is going to be telling Klipper what board to talk to. So we'll just go ahead and copy that out, and we'll go into main cell. So here in the config, there's multiple ways of doing things. Now I like to have like an EBB Gen2, or each one of my boards has its own um, config file. And all you need to do is just create a new file, name it whatever you want, and then .cfg. But of course, whatever you want it to be named, you have to remember that because what you will then do is go into your printer config and do an include. That's what this include here is. Okay. And that just tells the printer config, include everything inside this folder into the loading of the printer config. So it's pretty easy way to keep things nice and clean because obviously you see there's nothing in here. But if I go back over to this config here, there's a lot in here. So this is the full config, but everything's hashed out right now because I don't have anything connected to the EBB board. So I don't want it throwing up a bunch of errors. But what I did do is activate the thermistor that's built in underneath the TMC chip, so we can see both the so we can see the thermistor working, basically proving that our board is communicating properly. That's why that's all that's in there. I also hashed out here because I'm using it in the printer config. But if you put it here, This is what we're going to be using the serial command to make things talk to Klipper or talk for Klipper to talk to your board. Um, but right now I'm just leaving that hashed out. So it's up to you how you want to work that. If you have questions about what I mean about all this stuff, definitely drop them down in the comments. But if you've already set up printer stuff, you should understand what I'm saying here. So let's go to the next step here. Get into our printer config. And then for our MCU EBB, obviously we're not using CAN bus. So I can get rid of this one. Just hash that out for now. And then I want to add a new line. And then I'm going to do a serial communication. That's what the USB is. The serial and then colon space. And then that's where we want to paste in that whole line that we had uh, from our list of the dev. So this is the full serial name. Okay. It is important that not just this part. You want to do the whole thing because it's basically asking the path to what your chip is communicating on. So it's important to have this dev serial part also. So there. So now we have that serial communication in the right spot. Everything else, like I said, is just basic stuff to get things working. So once you put in your serial line, you should be able to save and restart. And if everything goes right, it should start communicating. And there we are. So here's your MCC, the EBB. If I click on there, you can see all the different available pins and all that fun stuff. But you can see it's communicating. This is our EBB. And if I go over to the dashboard, since I set up the temperature sensor, there's a temperature sensor running. So that's it. That's how you get it set up. The rest of it is going to be up to you setting up your printer config, of course. You're going to want to make sure that all your printer config stuff is communicating properly. And set up your pins, your extruder information, but uh, all that stuff is obviously a little bit more advanced than this. This was just predominantly set up for showing you how to get your USB communication working in order. So now it's all about getting your printer working with the equipment that you're plugging into it. Any questions? Leave them down in the comments. I'm more than happy to help you out with what I can. Anybody else down there in the comments, if you see that I'm not able to get to it or if you have a good answer, jump on in, help us out. Um, Another big thank you to our video sponsor, PCB Way. It's a big help. If you guys are interested in doing any exotic 3D printing, metal stuff, you want to get a metal bracket for holding your stuff together, you can get that made by them, and it's really cool stuff. Really nice. Great quality so far from what I've got. Or if you want to do some sort of custom PCB boards, of course they do that stuff too. But check them out. They're really cool people, really easy to deal with. Pretty affordable prices considering it's drop ship, one-off manufacturing. Typically, those things are many thousands of dollars to get those things done. But anyways, check them out. Huge thank you to all of my subscribers, everybody new. Welcome aboard. Everybody that's still hanging on. Thank you so much for hanging in there and sticking with me. I really do appreciate that. A quick plug, I do have a Patreon account set up. It's nothing special except for if you want to help out the channel, you can drop some stuff. In the future, I might be doing more, but I need to figure out that to give kind of a side platform on that. But if you're interested in helping out the channel, that's always a nice thing, but I'm not going to beg you for that. But I do want to say massive thank you to Steve, my first Patreon that has been giving me some cash on there. That's a awesome help. I again, I'm still blown away that even started up. Thank you very much for that. Anybody else interested? That'd be really cool. Great help, but not required. So yeah. Other than that, hopefully this video was helpful. If you again have any questions, let me know. And until next time, get out there and make something. Thank you for watching.